Everyone, this video is an exercise 90 question 5. So we are given the triangle PQR and the sides are given algebraically with some algebraic expressions. And also we know that the angle QPR is 30 degrees. So essentially we have a triangle which let's say looks like this. And so here's PQR, QPR. And we know that the angle QPR is 30 degrees, which is here. So PQ is x plus 2 centimeters. And then PR is 5 minus x centimeters. And the area of the triangle is just 8 centimeters squared. So in part A, we want to show that the area is equal to this expression. All right, so we just need to know the formula of the area of the triangle because this is a very useful formula. So half AB sine theta. And obviously I'm not talking about the basic formula of triangle, which is height times base, because we can't really use that in this case. So this is another formula for the area of triangle, and we often use this when we have basically two sides and the angle in between of them. And in this case, we just need to substitute these values. So we have x plus 2 times 5 minus x sine 30. So sine 30 is just a half sine 30. Right, so we just now need to simplify, and then basically we are done. So we have half here times a half, which is 1 over 4. And then inside the brackets, we have 5x minus x squared plus 10 minus 2x. And this is equal to 1 over 4. 10 plus 3x minus x squared, which is exactly what we wanted to show. Right, part B, which is more interesting. So we want to use the method of completing the square or otherwise to find a maximum value of A and give the corresponding value of X. Right, so I'm going to solve this with the method that is actually called differentiation. And if you haven't done the differentiation chapter, then you basically need to know that. So essentially, in this case, we first differentiate, and I will leave the completing the square as a practice for you, so you can complete the square and then check if you get the same answer. But anyway, so to differentiate, we obviously we can first just rewrite this as a is equal to 10 over 4, so we just expand this, plus 3 over 4x minus x squared over 4. Now we differentiate this with respect to x basically. So the first term is just a constant that differentiates to 0. The second term differentiates to 3 over 4. And the final term differentiates to minus a half x. Now, we set this equal to 0 because we want to find the maximum. So we set this equal to 0. That means we have half x is equal to 3 over 4. So we just rearrange this and we get 6 over 4, or simply 3 over 2. Now, we can obviously double check that if this is the maximum. So we find the second derivative, d squared a by dx squared, which is essentially minus a half. So yeah, this is definitely a maximum because the second derivative is negative for all values, in fact. So now that we have the x values, so we have answered half of the question because it says find a corresponding value of x. Now we want to know what's the basically the value of a. So all we need to do in this case is just we basically substitute 3 over 2 into the main equation here. So we find a. So a is equal to 10 over 4 plus 3 over 4 times 3 over 2 minus 3 over 2 is squared over 4. So this is equal to 10 over 4 plus 9 over 8 minus, so here we get 9 over 4, but then 4 goes to the denominator and we have 9 over 16. So, and the answer is 49 over 16.